PSSC 1. Utilize IEEE Standard 1562-2021, Section 10, Worksheet 1 to properly size the PV system to deliver at least 100 watts on a clear day. For our test, we connected our two solar panels in series to the MPPT controller, which has the discharged battery as its load. The app for the MPPT shows 174 watts, which is pretty close to the 171 watts given by the multimeter and DC clamp meter. PSSC 2. When the solar panel temperature sensor reads 125 Fahrenheit or greater, water will be dispensed to the solar panels at a rate no less than half a gallon per minute from the water source. The system will continue dispensing until the temperature reads below 110 Fahrenheit or the user configurable timeout is exceeded. This test was split into 3 parts to verify the different aspects of the PSSC. First, we show that when the temperature exceeds 125, the valve turns on and water flows. We measure the time it is flowing and then check how much water was in the bucket. After the water settles, we end up with 1.5 liters with a flow rate of 2.86 gallons per minute. For the second test, we raise the temperature over 125 and make sure the valve opens. We then put the probe in water to cool it below 110 and ensure the valve closes. Part of this is sped up since there is water caught in the hose between the nozzle and the valve, which you see dripping out here. For the third test, we hold the temperature over 125 to check that the configurable timeout, in this case 30 seconds, successfully turns off the valve. As you can see from the timer, the LED indicator showing that the valve is off changes 30 seconds after it opens, even though the temperature is still over 125. PSSC 3. The solar tracking system will rotate over a range of motion from the stow position to at least 70 degrees around its horizontal axis. For this test, we used a protractor and a plumb line to check the angle of the panel. Our starting angle was recorded as 23 degrees, and we then connected power to the linear actuator and waited for it to reach maximum extension. The final angle was 121 degrees, leading to a range of motion of 98 degrees. PSSC 4. The control panel microcontroller will be able to be reprogrammed via USB port to allow for additions in future projects. This test started with code on the board that sets this LED to red, and as you can barely see here through the glare, the new code sets the LED to blue. We then used the provided expressive tools to upload the code to the board, and as a result, the LED changed to blue. PSSC 5. The motor controller will start the adjustment of the solar panel's orientation within 10 seconds of receiving a position update from the sun tracking algorithm. The algorithm will recalculate the position every 10 minutes. The results of this calculation may be a new position, or the algorithm may opt not to move the panels if the sun has not moved enough. This clip was taken right after the calibration sequence, where the system determines the potentiometer values for the maximum and minimum angles. In order to not have an extremely long video, we changed the timer from 10 minutes to 30 seconds, after which the system performs its first solar calculation, and you can see the LED turn red to indicate that the signal was sent to the motor controller. For this first update, the panel has a long way to rotate. We then wait another 30 seconds to ensure the timer is working, and you can see the much smaller adjustment that has to be made. Both times, the motor controller responds well under 10 seconds.